At first glance, there is nothing unusual about a Corsair Vengeance DDR5 memory module. It carries the familiar design PC builders have trusted for years, advertises standard DDR5 6000 performance, and promises compatibility with both Intel and AMD platforms. To most buyers, it looks like another routine hardware purchase. But a closer inspection reportedly revealed something that caught the attention of semiconductor analysts. Instead of memory chips supplied by Samsung, SK Hynix, or Micron, the three companies that have dominated the global DRAM market for decades, the module appeared to contain chips manufactured by China's Changxin Memory Technologies, better known as CXMT. On its own, that discovery does not prove that the industry's balance of power has changed. It does not mean CXMT has surpassed the established leaders in technology, production scale, or reliability. Yet it raises a much more important question. Has the memory industry reached a point where buyers finally have another credible supplier? Sometimes the biggest shifts in technology begin quietly. They are not announced through record-breaking benchmarks or dramatic product launches. Instead, they appear inside everyday products that most people never examine closely. If CXMT is beginning to find its way into mainstream consumer hardware, the real story may not be about one memory module at all. It may be about the first signs of a more competitive global DRAM market. To understand why CXMT's reported appearance inside a mainstream memory module has attracted so much attention, it helps to understand how unusual the DRAM industry really is. Unlike many areas of consumer electronics, memory manufacturing has never been a business where new competitors appear every few years. Over time, the market has narrowed until just three companies, Samsung, SK Hynix, and Micron, came to supply the overwhelming majority of the world's DRAM chips. Whether the memory ended up inside a gaming PC, a workstation, a cloud server, or a business laptop, there was a strong chance that the silicon originated from one of these manufacturers. That level of concentration was not created by chance. It was the result of decades of technical expertise, enormous financial investment, and repeated industry downturns that eliminated weaker competitors. Building a modern memory fabrication facility requires billions of dollars before a single chip is sold. Even after production begins, companies must achieve exceptionally high manufacturing yields to remain profitable. A small increase in defective chips can quickly erase profit margins. The industry's cyclical nature makes the challenge even greater. During periods of strong demand, manufacturers expand production aggressively. Eventually, supply catches up, prices fall sharply, and profits shrink across the entire market. Companies with weaker finances often struggle to survive these downturns, while larger producers use their scale and cash reserves to continue investing until conditions improve. Over decades, this process gradually reduced the number of major players. The result is a market where countless brands sell memory modules, but most of them depend on the same limited group of DRAM manufacturers beneath the surface. That is why the emergence of a credible fourth supplier is significant. It is not simply another company entering the market. It represents the first meaningful challenge to an industry structure that has remained remarkably stable for many years. Memory is one of the least visible components inside a computer, yet it is among the most difficult to manufacture successfully. Most users notice RAM only when they run out of it, but behind every memory module is a manufacturing process that pushes semiconductor engineering to its limits. Dynamic random access. Memory, or DRAM, stores data inside billions of microscopic memory cells. Each cell holds a tiny electrical charge that represents a single bit of information. Because those charges naturally fade over time, the memory controller must refresh every cell thousands of times each second to preserve the stored data. This constant cycle happens continuously while the computer is running, without the user ever noticing. The challenge is not simply building billions of these cells. Every one of them must behave consistently under different temperatures, workloads, and operating conditions. Even a small manufacturing defect can create instability that only appears after hours of heavy use. A memory module may seem perfectly functional during everyday tasks, but develop errors when handling demanding applications such as scientific computing, video production, or artificial intelligence workloads. For manufacturers, consistency is just as important as speed. Producing a fast memory chip in a laboratory is one achievement. Producing millions of identical chips that all meet the same quality standards is an entirely different challenge. That requires extremely high manufacturing yields, where the overwhelming majority of chips on every silicon wafer function correctly. Low yields quickly increase production costs and make it difficult to compete with established manufacturers. This explains why entering the DRAM business is so difficult. Success depends not only on advanced engineering, but also on years of refining production processes, reducing defects, and improving reliability generation after generation. These are capabilities that cannot be developed overnight. For any newcomer, including CXMT, the real milestone is not demonstrating that a chip can work. It is proving that the same level of quality can be delivered consistently at commercial scale. Compared with the companies that have dominated the memory industry for decades, CXMT is still a relatively young manufacturer. Founded in 2016, the company entered a market where its competitors already possessed decades of manufacturing experience, extensive customer relationships, and some of the most advanced semiconductor facilities in the world. Rather than immediately competing at the highest end of the market, CXMT followed a more gradual path. Like most new semiconductor manufacturers, it first focused on improving manufacturing yields, refining production processes, and building experience with increasingly advanced generations of DRAM. This approach may not generate headlines, but it is the foundation of every successful chipmaker. Before a company can compete on cutting-edge performance, it must first prove that it can manufacture reliable products in large volumes. Over the past several years, CXMT has steadily expanded its DDR5 portfolio, introducing memory solutions aimed at desktop computers, laptops, workstations, and servers. The company has also introduced higher density memory dies that enable configurations such as 24 GB and 48 GB memory kits, capacities that give system builders additional flexibility between traditional upgrade options. Still, published specifications alone rarely convince major customers. Semiconductor companies frequently announce impressive technical achievements, but commercial success depends on something far more difficult: earning the confidence of manufacturers that will integrate those components into products sold around the world. That is why the reported appearance of CXMT memory inside a Corsair-branded module is noteworthy. While Corsair has not officially confirmed the configuration, the reports suggest that a globally recognized memory brand may be willing to qualify and sell products using Chinese-made DRAM. Even if that rollout is currently limited to specific regional markets, it represents a meaningful step beyond laboratory demonstrations or marketing presentations. For semiconductor manufacturers, commercial adoption is often the true turning point. Once products begin reaching real customers, engineers gain valuable feedback, manufacturing processes continue to improve, and confidence gradually builds throughout the supply chain. In this industry, credibility is earned through shipments, not announcements. The timing of CXMT's emergence is not accidental. It coincides with one of the biggest shifts the memory industry has experienced in years: the explosive growth of artificial intelligence. As AI models become larger and more computationally demanding, technology companies are investing heavily in specialized accelerators, capable of processing enormous amounts of data. These processors rely on high bandwidth memory, or HBM, a type of memory designed to deliver far greater data transfer speeds than conventional DDR5 modules. Unlike desktop memory, HBM stacks multiple memory dies vertically and places them close to the processor, dramatically increasing bandwidth while reducing power consumption. For companies building AI infrastructure, this technology has become incredibly valuable. As a result, Samsung, SK Hynix, and Micron have devoted significant manufacturing resources toward expanding HBM production, where profit margins are substantially higher than those of standard consumer memory. However, semiconductor manufacturing capacity is not unlimited. Producing advanced HBM requires considerable wafer resources, engineering expertise, and production time. Every factory that shifts more capacity toward premium AI products has fewer resources available for traditional DRAM. The established manufacturers are understandably focused on serving the fastest growing and most profitable segment of the market. But millions of desktop computers, business workstations, gaming systems, and mainstream servers still require conventional DDR5 memory. That demand has not disappeared simply because AI has become the industry's primary focus. This changing balance creates an opportunity for newer suppliers, such as CXMT. The company does not need to outperform the industry's most advanced HBM products to become commercially successful. Instead, it only needs to provide reliable, competitive DDR5 memory that helps fill the supply gap left as larger manufacturers prioritize premium AI markets. In many industries, disruption begins when market leaders move toward higher value opportunities, leaving room for new competitors to establish themselves in segments that receive less attention. The AI boom may be creating exactly that kind of environment for the conventional DRAM market. Rather than competing directly at the industry's technological frontier, CXMT may be benefiting from a broader shift in manufacturing priorities, one driven not by weakness among established leaders, but by their pursuit of even greater opportunities. For companies that sell finished memory products, having access to another reliable DRAM supplier offers advantages that extend well beyond lower component costs. It changes the balance of power throughout the supply chain. Brands such as Corsair, Kingston, G-Skill, and others design, validate, and market memory modules. But they generally do not manufacture the DRAM chips themselves. Instead, they purchase memory dies from specialized semiconductor companies, integrate them onto circuit boards, perform extensive compatibility testing, and package them as finished consumer products. When only a small number of manufacturers control the supply of those chips, module brands have limited flexibility. If one supplier reduces production, another experiences manufacturing issues, or all three prioritize higher margin markets, buyers have few alternatives. Prices rise, delivery schedules become less predictable, and negotiating power shifts toward the chip manufacturers. Introducing a credible fourth supplier changes that equation. Even if CXMT initially captures only a modest share of the market, its presence gives module manufacturers another sourcing option. That alone can strengthen their negotiating position. Existing suppliers know that customers are no longer completely dependent on the same three companies for future orders. History shows that supply shortages often accelerate this process. During periods of abundant inventory, manufacturers tend to remain with familiar suppliers because switching introduces additional testing and qualification costs. But when supply becomes constrained or prices climb rapidly, companies become far more willing to evaluate alternative sources that previously received little attention. For CXMT, this may be one of the most important opportunities created by today's market conditions. It does not need to replace Samsung, SK Hynix, or Micron overnight. It simply needs to demonstrate consistent quality, dependable delivery, and competitive pricing. Once manufacturers become comfortable sourcing even a portion of their inventory from a new supplier, that relationship can gradually expand over time. In the semiconductor industry, gaining a customer's confidence is often the hardest step, and once that barrier is crossed, future growth becomes considerably more achievable. In the semiconductor industry, impressive specifications are only the beginning. A company can announce faster speeds, larger capacities, or more advanced manufacturing processes, but none of those achievements automatically translate into commercial success. What ultimately matters is whether customers trust the product enough to deploy it at scale. That trust is earned through consistency rather than headlines. A memory chip must perform reliably across thousands, or even millions, of systems operating in different environments. It must maintain stability under heavy workloads, tolerate changing temperatures, and deliver predictable performance over years of continuous use. Even a very low failure rate can become a major problem when products are shipped in high volumes to PC manufacturers, enterprise customers, or cloud providers. This is why qualification is such an extensive process. Before adopting a new supplier, hardware companies conduct months of validation, testing compatibility with different processors, motherboards, firmware versions, and operating conditions. They are not simply evaluating performance, they are measuring long-term dependability. If the reports surrounding the Corsair memory module are accurate, the significance lies less in the module itself than in what it represents. A recognized consumer brand would likely have completed its own testing before offering a product backed by its warranty and reputation. While that does not place CXMT on equal footing with Samsung, SK Hynix, or Micron, it suggests the company may have reached a level where its products are considered commercially viable. This distinction is important because technological leadership and commercial acceptance are not always achieved at the same time. Many companies develop promising innovations that never reach large-scale production. Others begin with products that are merely competitive, then steadily improve through manufacturing experience and customer feedback. For CXMT, every qualified shipment provides more than revenue. It generates real-world data, strengthens customer relationships, and refines production processes. Over time, those incremental improvements can become a powerful competitive advantage. In semiconductors, sustained execution often proves more valuable than a single technological breakthrough.